Welcome to part 2 of our P4 lesson on absolute value equations and inequalities. So if you recall, the objective was we're going to solve absolute value equations and inequalities. The first part was equations, and right now we're going to look at inequalities. Right? There is a second note sheet attachment that hopefully you got through Google Classroom. So remember our rules for yesterday. Isolate the absolute value bars. Then you're going to split it into two equations, and then you solve and check. What you're going to find for the absolute values is for absolute value inequalities, it's not much different. One big difference, and we'll look at that. All right, so let's talk about d is greater than 4 first. The absolute value is isolated, so that part's the same. We're going to split it into, instead of equations, two inequalities now. So if you assume what's inside is positive, then d is greater than 4. If you assume what's inside is negative, not only will that 4 flip to its opposite, the inequality symbol will flip as well. Okay. The way that I have that written, I'm actually going to flip it around, just so that way numerically the negative 4 comes on the left. So what I'll say is d is less than negative 4, or d is greater than 4. That's a compound inequality. The reason why I'm writing or is because they're going in opposite directions. Like if I were to graph this, let's say 0 is here, that makes negative 4 here. Be an open circle at negative 4 for this part. It's open because it's just less than, and then you shade to the left. D is greater than 4. 4 would be here, open circle at 4. Then we shade that way. And again, this is or because they are going in opposite directions. They're not pointing at each other. Okay. A little more complicated, but same concept. The absolute value bars are isolated. So we will just split it into two inequalities now. If I assume what's inside is positive 2x minus 3 is greater than 7. If I assume what's inside is negative 2x minus 3, the greater than flips to less than, and then it'll be negative 7. Now you just solve both separately. I'm going to add 3. I get 2x is greater than 10. Divide by 2, I get x is greater than 5. Add 3 here. I get 2x is less than negative 4. I divide by positive 2. Even though that's negative, it doesn't matter since I'm dividing by positive 2. It ends up being x is less than negative 2. I don't flip that because I'm dividing by a positive. Again, it doesn't matter that that number is negative. So if I go ahead and write my compound inequality, this will also be or because they're pointing in opposite directions. So let's say 0 is here. That puts negative 2 here. Open circle. Shading to the left. That puts 5 here. Open circle at 5. Shading to the right. Okay. Notice 2 in a row where the absolute value inequality started with greater than and it ended with or. Right. This one's also greater than, so let's see if we end up with or again. No need to do anything with the absolute value bars. They're already isolated, so I can just go ahead and split. So 2x minus 5 is greater than 3, and then 2x minus 5 is less than negative 3. I'm going to add 5 to both sides. 2x is greater than 8. Divide by 2, you get x is greater than 4. Woo. Here I'm going to add 5. So I get 2x is less than positive 2. Divide by 2 and you get x is less than 1. So x is less than 1 or x is greater than 4. So if 0 is here, 1 would be here. and I'm shading to the left. That would make 4 here, and I'm shading to the right. Okay. Again, started with greater than, ended up with or. Now let's look at what happens if it's less than. So I'll split it just the same. If I assume what's inside is positive, A is less than 4. If I assume what's inside is negative, it'll be A is greater than negative 4. If I flip them around, if A is greater than negative 4, and I have A is less than 4. If I put that on the graph, let's again assume 0 is here. Negative 4 would be here. That would be an open circle here, shade it this direction. And then if I assume, again, 0 is there, so then 1, 2, 3, 4, that'd be an open circle at 4, and it's shading to the left. So this is an AND statement. You can either leave it as two inequalities separated by the word AND, or you can write it as one compound statement. You can only do this with AND statements. You can't do it with OR because the ORs are separate. So now we have a situation where it started out as an absolute value inequality with less than, and it turned into a compound inequality with and. Right? So this one a little more complicated, but still nothing else. It's already isolated. So we're going to split it. You have 14k plus 3 is less than 12. And you have 14k plus 3 is greater than negative 12. All right, we're going to subtract 3. You get 14k is less than 9. Divide by 14, you get k is less than 9/14. Here you're going to subtract 3. You get 14k is greater than negative 15. Divide by 14, you get k is greater than negative 15/14. I'm going to flip it around. You have k is greater than negative 15/14. So it's greater than the smaller number, and it's less than the bigger number. In terms of a graph, you don't need to be too precise, other than, all right, if 0 is here, negative 15/14 is just slightly more negative than negative 1. So let's put an open circle here. 9/14 is a little more positive than 1/2. We'll put it there. So open circle here. It's not a big spread, but you would shade in between. Okay, and that's the only part of the graph that would be shaded. Again, another situation where less than in an absolute value inequality became compound with and. Here, less than also became and. So that is a pattern. If you're starting with an absolute value inequality that's greater than, it will end in a compound inequality with or. If it's an absolute value inequality with less than, it will end up as and. All right, so a couple reminders. Isolate the absolute value. Isolate the absolute value. We haven't had to do that yet, but we will with the next example. Write two equations or inequalities, so that works for both now, and then you solve and check. I would also recommend writing for absolute value inequalities greater than becomes an or, less than becomes an and every time. So that's something to remember. And it also helps, right? Like, so right now I'm looking at an absolute value inequality, it's less than. That means I'm going to end up with an and compound inequality. If I don't, something went wrong, okay? Isolating the absolute value inequalities. So isolating the absolute value part of the inequality we need to do. We haven't had need to do that with any examples today. So let's do that first. Now I've got 3 times 2x, absolute value of 2x plus 6 is less than 24. Divide both sides by 3, and you get absolute value of 2x plus 6 is less than 8. Okay. Now I can split it like we have been doing. All right, so 2x plus 6 is less than 8. 2x plus 6 is greater than negative 8. Right? I think once you get comfortable with this, the most common mistake I see is people trying to split an equation or an inequality before you have the absolute value bars isolated. That needs to happen first. Now I'm going to just subtract 6. You get 2x is less than 2. Divide by 2 and you get x is less than 1. Here I'm going to subtract 6. I get 2x is greater than negative 14. Divide by 2 and you get x is greater than negative 7. So if I write it as a compound inequality, x is greater than negative 7 and x is less than 1. So if I assume 0 is, let's say, here, 1 is here, open circle, shade to the left, and then 1, 2, 3, 4, 5, 6, 7. Negative 7 would be here, open circle here, shading to the right, so essentially you're shading everything in between. Last one, I think it might make sense if you just pause the video, you try it yourself, and then you see if my answer ends up being the same. All right, so pause it, and then I'll explain. You can unpause it and then see if you're the same. So the first thing you need to do is isolate. So I'm going to add 5 to both sides. Now I've got negative 2 times x plus 1 is greater than or equal to 2. The greater than makes me think it's going to be an or statement, but let's see what happens here, because when I divide away that negative 2, I'm dividing by a negative 2. The rule about flipping the inequality symbol still holds. So now that greater than or equal to turns into less than or equal to. 2 divided by negative 2 is negative 1. Okay. At this point, it's a little tricky because not only can an absolute value not be equal to a negative, well, it can't be less than or equal to a negative as well. So this is actually no solution, right? Because the absolute value can't be less than a negative, right? It has to be positive or 0. So at this point, you can't have a negative, right? Especially if it's less than, okay? If it was greater than, then you could solve it and then see if, you had any extraneous solutions, but otherwise, this one is actually no solution. So kind of a trick question. I apologize if you tried it and didn't catch that before. So that's it. So I'm going to embed the second part of the practice in the same P4 practice. I think that's just easier to do it that way instead of having a separate assignment in CK12. So that'll be there by the time you're done taking the notes. And then tomorrow, I should say Wednesday, we'll do the lesson quiz for just both things together. Okay. Reach out to me if you have questions, whether it's email, whether it's chatting into the class, whether it's jumping onto a breakout room. Get help if you have questions. Whether it's a question about the notes or you just want to start the practice and see if you have questions pop up, that's fine too. All right, but I'm here to help.